Hey guys, how's it going? I just wanted to demonstrate a couple of stuff here using my AWS account. This is about the VPCs, the subnets, the route tables, the internet gateway, and reaching your machine, right? If you're wondering why we need all these, if you just create a default Amazon account, you find that you have a default VPC in place, and a lot of things are defaulted by Amazon for you, so that basically when you are at a stage to launch your virtual machine on Amazon or whatever is the service, right? For example, the RDS, and use it straight away. But these are the things that Amazon creates for you in a ready-made thing. But then the things are whole different when you want to actually create something which is very custom to an organization, right? Like for example, let's assume that you're trying to create a case where a lot of machines for your organization needs to be put into Amazon. Not that it can't be put on the default VPC, it can be, but then VPCs give you more flexibility to design, isolate stuff, make only certain machines reach outside and all that. So it is better to learn that. So that's the whole point of it. I'm on my Amazon account, and let me log into it. So just assume that your VPC is like a network, a LAN network that you have in your lab, right? I mean, that's something like that. I mean, it's not actually a LAN, but then more than that, if you're familiar with the concepts of regions in Amazon, which are geographies, availability zones, which are data centers, VPCs are region specific, and they span across the availability zones. Amazon at the back end takes care of how to communicate between your machines that are placed in different data centers, even though they are belonging to the same VPC. So VPC can be assumed as a software defined network thing that is given to you by Amazon for you to design, right? So I'm on the AWS console now. Let me go ahead straight and start creating a VPC before we talk a lot about it. So a couple of things, as I said earlier, Amazon gives you a default VPC. VPCs have IPv4 address blocks and IPv6 capability as well, but then from an IPv4 perspective, the largest size of the CIDR block that you can have per VPC is /16 CIDR block, the classless interdomain routing, if you are aware of. That's what CIDR stands for. And yeah, CIDR block of /16 is the largest thing that you can have on a VPC. What's the smallest? /28. That's the smallest CIDR block that you can have. So what that essentially means is that you can have something between 4,000 odd, not even 4,000, even less than that, 2 power 4, right? So something between 2 power 4 to 65,000 odd IP addresses that you can have in a VPC. Now, don't get confused between the terms of VPC and CIDRs, and think about the actual subnets. CIDR representation of a VPC is the universal space of IP address that you can have totally, and further these CIDR blocks can be subdivided into subnets inside your VPC as and when you want it, right? So that is the whole point of it. So let's start creating a VPC now, and while let's select a VPC. Right, so this is an IPv4 CIDR block. I'm asked for a VPC name. My VPC name, let me say this is a dev VPC01, right? So that's the name I wanted to. With a single public subnet. This is something new that I'm seeing here, right? So I don't need this. Let me get onto VPC again. I'll get into your VPCs, and I'll start creating a VPC from here. So this is not that I can create a VPC that way using a public subnet. It is possible, but then this is the way that I am familiar for explanations, right? So I'll give a name tag as dev VPC01. That's the name I want to. As I said, this is the universal block of subnets that I'm giving. I'm taking a /16 CIDR block for this. I don't want an IPv6, and okay, so now there are two options. Tenancy, the tenancy of the VPC. Do you want it to be a multi-tenant VPC? Means the machines that are in this VPC basically are on a shared basis between others that use Amazon account, right? So that's the default thing, the multi-tenancy one, dedicated everything for you, all your instances, all your stuff placed together only for you, right? So that's the dedicated thing. So now before we do anything, or just let's say as created, and a couple of things here to note, right? There is a default VPC, and it's a /16 VPC CIDR block that's there, right? And the default subnets that Amazon creates for you inside these VPCs are in /20, right? So if you want to see that, just go ahead and look here. All of them are a /20 subnet, right? So that's the thing. So 4091 IPs available, right? So that's the thing. So basically it is like this. An IP address has 32 bits, out of which 20 bits from the network part and here, right? So which means which essentially gives me 12 more bits of IP addresses that I can do with. I can create subnets on top of it, right? So that means which is 2 power 12 kind of a number, which is 4096, and 5 IPs are used by Amazon for its own thing for broadcasts and gateways and VPC network itself and all that, right? So let's not worry about that for now. And the next thing I wanted to tell about VPCs is that per VPC you can have 5 CIDR blocks, and essentially one of them is a completely private block. Like for example, the numbers are 10 dot something, or 172 dot something, or 192.168 dot something, right? So these are some of the ranges that you can create, one of them at least, right? And then you can choose the rest of the addresses, rest 4. It is little tricky. I found it very difficult to find what is an upper limit of the number of CIDR blocks that I can have per VPC, and then finally did some trial and error to find that it's 5. Okay, before deciding on a real practical case of CIDR block that you are going to take, please talk to your network admins of your company, because there might be a hybrid use case that you might encounter, and you want the IPs from your data center to be distinct from that of what is there in Amazon, so that the migrations can pass through easily. If there is an IP conflict between these, you will land up in issues. Not that it can't be resolved, but then it is more complex resolving that. So it is the designing this way makes it better, right? So I have a default VPC now, and I go ahead and just create a subnet, right? What's a subnet? We all know what's a subnet, right? So I'll pick up this subnet name as pub sub dev01. That's my subnet. So what I'm intending to do here is to create a public subnet, which means the machines here will have a way to access the internet inbound and if possible outbound and all that, right? So that's the only thing that I want to do. I will select the correct VPC here. Pay attention here, right? So I'm picking up the dev VPC, which is the CIDR block that I defined here. That's there. I'll pick up an availability zone. If you see what is an availability zone is nothing but the data centers that Amazon has in a region, right? So that's what I'll pick up, an availability zone, and I'll pick up a CIDR block for the subnet. This is my subnet definition, right? So I'll say 10.0.0.0/24. So it's a smaller block of the /16 global address range I have for this VPC, right? So /24 again, 32 bits for the IPv4 -24, which gives me 8 2 power 8 IPs, which is 254 roughly, which translates into 251 that Amazon really gives you, right? So that's the thing. So as created, okay, here is my subnet that I've created now. So before we move on to anything, we must know how to create an instance in Amazon and put it into the subnet that I have, right? So let me go ahead and create an EC2 instance. Getting onto the EC2 console now, and I'll just get into the instances tab and start creating a new instance. I'll prefer a Windows instance here, so I'll just create an instance. So what are AMIs? Amazon machine images. They are nothing but your images from which you can create virtual machines, right? Just kind of a Xerox copy. You do Xerox copy of your name, image, and create more machines out of it, right? So I'll pick up the Windows tier, the free tier Windows that I'm eligible for, Windows 2016, T2 Micro, the size, right? I will I need one instance, and I will actually pick up my VPC in which I need to place this. Since I've defined only one subnet and I've told that please place the subnet in US East 1A, right? I'll pick up that subnet that I've chosen. So think about it like this, right? I mean, if you're designing a redundant setup, let's say you're designing a cross data center cluster that you need, then what you essentially do is define two subnets, place each of those subnets in two different availability zones inside a particular region, and that way if your one data center goes down in Amazon, the other one is there. It's up to you to how to cluster them, but then from an infrastructure physical placement of these virtual machines, you can be rest assured that they are completely in a different data center now, right? So as of now, I just have one data center because that's what I intended to do, right? I mean, and I have one subnet. And remember this again, all the subnets that you create can span across all the availability zones that are there in the region that you have, right? Or you can decide to place all of that subnet into one availability zone, right? So that's the whole point of it. So Amazon gives you a lot of choices. If you want to have something like a database server and a web server talking to each other, and you feel that there would be a latency issue, put them onto a subnet that is there inside an availability zone, and if the number grows up, don't worry about it. All of the subnets can be placed in the same region and you can grow it, right? So you have all that freedom to do, right? So now auto assign IP address. So public IP, at this point I'm not interested about a public IP. A public IP is something that I would be able to connect from the internet, right? I need a lot of stuff to do before I can do that, so I'll say disable that for now. I'm not worried about the IAM roles and the domains now. Shutdown behavior, termination protection. Can I protect this virtual machines against somebody accidentally terminating it, right? CloudWatch, the monitoring stuff, right? Tenancy, this is an interesting part. So shared, as you know, that's the default model that Amazon gives you, which means that the host that runs your virtual machine is shared between different tenants, different users, and all that, right? So that is one thing. So the next two things are a little tricky. Listen to this: dedicated and dedicated host. Let's talk about the dedicated host. Amazon gives you a physical server in this case, and your instances are all placed in the same physical host now, and that is physical host for you, right? And when you bump the instance, which means start and stop, reboot your instance, Amazon assures that they are placed in the same physical host that is given to you, right? So that's the beauty of it. Whereas dedicated, just the second option, right? The dedicated one says that place all my virtual machines together and only dedicate that host for me. But then Amazon has freedom to place these virtual machines into a different cluster if you reboot them or bump them, right? So the difference between dedicated host and dedicated is that you have a set of instances. If you think that you need the physical, you are worried about the physicalities of the machine, right? I need this machine and I want to look at where my VMs are placed and stuff like that, right? I want it to be on the same host and all that, right? Regulations. So you can choose a dedicated host, whereas if you're just worried saying that all my instances, for example, should run in the same host kind of an environment, right? So that means put it on a dedicated, and you don't worry about where Amazon switches these. Amazon ensures that all your hosts will be placed in one host, all your guests will be placed on one host. That host may not be dedicated to you in case of a second option, right? So that's the whole difference about it. Of course, each of them carry additional charges, so I'll pick up the shared model. And GPUs I'm not interested with. I can add more network interfaces to this machine, which I'm again not interested with. I'll say next, add storage, elastic block storage, right? So that is the thing. So this tier can take an EBS, right? What is EBS and what is an instance store? That's a key difference that I wanted to point out here. Amazon has something called as an instance store, so which means it is very trivial storage, which says that okay, once I reboot my machine, all that data that I put on my disks are lost, whereas EBS is something permanent, right? And then there comes S3, which we will not talk about now, but then there is instance store and then elastic block storage. Elastic block storage is availability zone specific, and the data stays in the disks even after reboot, but then in case of an instance store, it doesn't. That's the whole difference. So we are picking up an EBS, and I'll pick up a 30 GB disk, and I'll just say review and launch. The last thing that I need is security. Okay, let me go through this, right? So I was in add storage, right? I'll go through each step. I don't want to bump steps here, right? So I don't want to jump steps, not bump steps. So I'll add tags to this next, right? The tags are nothing but I want to identify instance. I'll call this as a name of the instance. I'll call this as my win16 ins01, right? So that's my instance. It's just some name to identify it, right? So they can be up to 50 tags per instance. That kind of Amazon gives you. The next one is an interesting thing. The security group, right? Now on the security group side, I will decide to create a new security group, which I'll say that Windows Sec Group 01, right? So that's the one I wanted to create, Win Group 01, something like this, right? So what it says is allow RDP from a custom thing. I'll say anywhere, allow RDP from anywhere. So this, imagine security group like a firewall that sits in front of your machine. Okay, there are a couple of things to note about the security group, right? One is the security groups are only allow based, right? Which means I can only say allow RDP. I cannot say deny RDP, right? So that's not a possibility with security groups. How to do that? Deny, will come to that in route tables, and then there is network ACLs and all that advanced stuff. But then this is what is security group, and then security groups are stateful, right? So stateful is something that let's say you are logged into a machine through SSH and you do some operation like a wget, for example, through SSH. So stateful thing, there is query and then a response, right? The query goes out, and when the response comes through some other port on your machine, which is essentially blocked, the statefulness of SSH or the statefulness of the security group essentially says that okay, the initial request went through port 22, which is allowed as per the security group. So the response coming to that request is also allowed, which is more stateful, right? A stateless thing is things needs to be explicitly defined. And when we talk about network ACLs, we'll talk about the stateless things, right? I mean, you need to explicitly say that the request goes from an open port, which is this port, and then the response I know will come through a range of ports between this and this. So it has to be very explicitly defined, whereas that's statelessness, right? And this is, security groups are stateful things. So it knows that when I log into an SSH and then issue a wget, the response that comes back was through an SSH session, and it remains the state of the, and it remembers the state of what I requested for, and the responses flow back. So that's the whole thing about security group. The next thing is just launch this instance, right? Review and launch. I'll click on review and launch. I need a key pair. I'll choose an existing key pair which I have. So the PEM file that you have is all only private and only you have it. Amazon can't provide it back to you if you lose one. Right, so you lose access to the instance if you lose the PEM file. Be careful about it. Launch the instance. Okay, now let's go ahead. Services, EC2. Right. Something is launching, so that's the whole point here. So I have my Windows instance running, and if you see this, it only has a private IP. And let's just scroll down this, the details of this instance. I'll pick up this instance, and if you see, there is no secondary private IP, but most importantly, there is no elastic IP assigned to it or a public IP assigned to it, right? So this is one difference. When you launch something on your default VPC, you'll see that it gets a public IP and it gets a private IP. But whereas in a custom VPC, unless I choose to put a public IP on top of this machine, it doesn't, right? So that's the whole difference. Now let's talk about elastic IPs. What are elastic IPs? Generally they are public IPs, right? So the model is like this. If you basically have an elastic IP that Amazon gives you, you can attach it to any machine, right, that you have, and then basically reach them through reach to that machine through the public IP that you have, right, from an internet, right? So that's the whole point of it. So now let's go ahead and create an elastic IP for our machine. I am expecting we will get a failure, and let's discuss that scenario now, right? So I'll just go ahead and say allocate new addresses. I'll say allocate. That's pretty much it. I got an elastic IP now, right? So now close. Now let me go back to my EC2. This is my elastic IP, right? And it is not associated to any private IP or instance yet. So the next thing is I'll go to the instances and I'll say actions. Oops, sorry. I'll go to elastic IPs, actions, associate. I'll try to associate to the instance that I created. I'll pick up the private IP of the instance. Let's not worry about reassociation. This is about if your elastic IP is already used, should I reallocate? So first step, I'm attaching it to an instance, not to a network interface, right? So I'll pick up this associate. So this is the error that I actually wanted to show you. It says that I can't attach an elastic IP to your machine because you don't have an internet gateway, right? So what is an internet gateway? Internet gateway is a gateway through which your machine can be accessed via the internet, right? Now, what does Amazon say is that, hey boss, you have created a public IP, but now actually you don't have an internet gateway to access a machine publicly. Then what is the point of associating a public IP to this instance, which is in a VPC that doesn't have an internet gateway, right? So the next thing is just go ahead and create the internet gateway before we can do anything, right? So that's the thing. Okay, so now I'll do cancel. I'll go to I'll just go to services, VPC, right? And internet gateways. As simple as that. Create an internet gateway dev VPC IG01. Right, that's it. Created. That's it. And you see this is in a detached state. So what does it mean is it's not attached to a VPC yet. I'll say attach. I'll pick up the dev VPC and say yes, attach it. That's it. So now I've got the internet gateway attached to my VPC. Let me go to my elastic IPs now. I'll pick up the elastic IP, try to associate it, and I'll go about associating my machine to the elastic IP. And now the request succeeded, as you see here, right? So that's it. So now I have a mission. I have a public IP to it. I have a private IP to it, and an internet gateway. And you think that all is good, right? To connect to this machine. Let's look into this machine once more, and I'll say this has now a public IP and a private IP. Okay, is this IP pingable first? Let's try that. All right, let's try pinging our public IP. And here is my terminal. I'll say ping and do this. And I'm seeing that this is timed out. Now what can I do? We talked about security groups, right? Which is like a firewall. Let's look into that firewall. And I'll look into this firewall, and I'll say the inbound rule. I'll just start looking into the inbound rule in a minute. I'll say that, oh, I only have got RDP enabled. Now let me make, for simplicity, I'll say all ICMP. The ping response happens over ICMP, right? So I'll say anywhere this machine is RDPable and pingable. That's what I want to do, right? So I'll do this. Okay, so per VPC I can have 500 security groups. Each security group can have 50 rules like this, and a machine can be at the maximum attached to 5 security groups. So these are some numbers to keep in mind, right? So that's the whole part of it. I made it. Now you think that this machine is pingable. I go again, try to ping this machine. It's not. All right. So now what could be the next thing, right? So now let me get into the VPC and I'll look into the next component, which are route tables, right? Route tables are nothing but it tells you what to do with the traffic, right? That's all. They're routes, basically routes. So I'll try to create a new route table. I'll name this as pub sub01 RT, right? I'll associate it to my VPC. I'll create one. There are default route tables. You can't delete them in Amazon, right? As soon as a VPC gets created, you have a route table as well created, right? So these are some things that Amazon abstracts in the default VPC that gets created. It does this work for you, right? You don't need to be worried about that for a default VPC. But then when you're designing your own VPC, you need to be aware of all this, right? So now let's look into the rules. It says that any traffic that the subnet request which is falling in the VPC CIDR, route it locally. So now I'll write another rule which says any traffic to this subnet from anywhere, route it through the internet gateway, right? Which is like okay. So now the specificity of rules, that is what I wanted to talk of next. So I had a question when I attended this Amazon training asking 0.0.0.0/0 includes 10.0.0.0/16 as well, right? So how is it evaluated, right? So the answer is basically the first rule that gets evaluated in a route table is a more specific rule and then a general rule. In this case, the specific rule is the one that has clear numbers there, right? The subnet is clearly defined, 10.0.0.0/16. The range is defined there, whereas 0.0.0.0 is anywhere, right? So that's a general rule. So specific rules first and then general rules next. So just saving this, is that good enough? No. To this route table, I haven't associated a subnet yet, right? So I'll try to just go ahead and edit. I have this subnet. I'll associate it, and that's it. So now you expect the routes to be clear. Now let's try pinging the machine again. Okay, it's not pingable. Let's see why now. Okay, so we have thought about the route table, we have thought about the security group. Is there something on the instance that I can do, right? So that's the next thing that I need to worry about. So now let me try connecting to my instance over an RDP, right? Is that possible? Right, so that's what I'm trying now. So let's go ahead. I'll try to connect to this machine now. I'll try to get the password, browse it, put my PEM key here, take up the password. I can't remember this password, so I'll download the RDP file. I'll do that as soon as that is done. It's trying to initiate, negotiate a credential, and I'm able to connect to this machine. So okay, so now let's not log into this machine for now. So now the thing is, this machine is not pingable but RDPable. So it has to do with some firewall, right? We took care of the security group, we took care of the route table. What next? So it is the Windows firewall itself. So let's take care of that now. So I'll just get the password of the machine and log into this. See, this is my password. And let's see, do it this way. Edit. Put the password here. Close this. Okay. I'm done. Right. Now, while this machine loads up, alright, I'll try to Google how to open a firewall. Here it is. I'll say pick up the command prompt. Let's say ping google.com. Okay, so this machine can reach the outside world now. So right now I found this somewhere. Here is the command. So this is the command netsh advanced firewall something. Hello, I'm not a Windows guy, so I couldn't decode this. So let me go to this instance, do this. Now let me go to my command line, Start pinging the instance, and bingo, that response. And bingo, that response. Right, so that's the whole point of it. So that's pretty much it. So what we have done essentially is create our own VPC, put a subnet, launch a machine into it, write a security group for that machine that we needed, and then create an elastic IP, attach the elastic IP to that machine, which obviously failed because we didn't have an internet gateway. We created an internet gateway, attached the elastic IP to that machine, and then played around with the route table even after fixing security group and the route table in picture. What we found is that the machine was still not pingable. We went into the Windows and enabled the ping through the Windows local firewall, right? So that's the whole point of it. So the whole essence is now you know how to create a VPC, how to put an instance into it, and how to make it reachable through the internet, and what is the importance of internet gateway, right? So that's the whole point of it. Thank you very much. See you in next video. Thank you.